Okay, so we are talking about investigating the sine curve, and we're going to take a look at what we just did in a little bit more detail. If we take a look at this curve, okay, we're going to answer some questions about this curve on the other side. And to do that, what I want to do is I want to recreate that curve. So in essence, we're going to do it one more time, what we did on the first page, but it's so important that you're able to reproduce it that this is worthwhile. So you can speed me up if you want, but let's take a look at what we're doing here. So we're trying to talk about the sine curve. So the sine curve is a curve that's going to go on these axes. Now your vertical axis is going to be y equals sine theta, and your horizontal axis is going to be theta. Now we chose in the last one to work with theta comma sine theta as our ordered pairs. And in the last video, we chose to go up by 30-degree increments. So we went up 30 degree, 30 degree, 30 degree. So it was 30, 60, 90, 120, and that was wonderful. I'm going to go up by a different increment this time. Let's go up by 45, 90, 135, 180, 225, 270, 315, and 360. So that's a different increment that I'm going up by. I'm going up by 45s this time. My maximum, well, let's leave that for a minute. Let's pretend I don't know. I do know what my maximum is going to be, and you should be learning that right now, but let's pretend that we don't know. And so we'll put in for theta and for sine theta. So this is simply a table of values. And so 45, sine of 45 is going to be, let's see, 0.7071. Beautiful. And 90. So 90 sine is 1. And 115. Let's see, it's 135, sorry. 135 sine. It's going to be 0.7071, and 180 is going to be 0. And 225 is going to be negative, and 270 is going to be negative 1. And then 315 is going to be negative. And then 360 is 0. All right, so we've got a pattern happening like we had in the last one. We seem to be going up to a maximum of 1, and then back to 0, then down to a minimum of negative 1, then back to 0. So what we're going to do is we're going to start plotting some of these. So, I didn't put in 0. So sine of 0. And just in case we don't know, sine of 0 is 0. So the first point I'm going to plot is 0, 0. And that's 0 and 0. And the next one I'm going to plot is 45, 0.7071. And then it's going to be 90, 1, etc., etc., etc. So 45. So I'm going to go up to a maximum of 1. I'm going to go down to a minimum of negative 1. I can see that from here. And I'm going to go up to 0.7, so approximately here. Then I go up to 1, then I come back down to 0.7, then I come to 0, then I go down to negative 0.7, then I go down to negative 1, then I go down to negative 0.7, and I'm back to 0. And what we have is that nice curve that we saw earlier. The only difference is I sketched it using different intervals in my horizontal axes. But this is the sine curve. Okay? Some interesting things to notice about the sine curve is that it is periodic. It will continue. So if I go another 45 up to 405, is that right? 360 plus 45? Yeah, it is 405 degrees. So if I go up to 405 degrees, you'll notice that that's the same as 45 plus 360. Those are coterminal angles like we talked about. So if you had 45, and if you went all the way around plus 45, those are coterminal angles. They're going to have the same terminal arm, which means that 45 and 405, if I put them into my calculator, so 45 sine, you see the decimal, and 405 sine gives me the same decimal. Same thing's going to happen with 90. So if I think about going 90 degrees, and if I think about going, oh, you can't see, if I think about going 90 degrees, going 360 plus 90, so 90 plus 360 is going to be 430 degrees. So 430 degrees is going to be the coterminal to 90, so 90 sine is 1, and 430 degrees sine, oh, wait a second, what did I do wrong? Made a mistake. 90 plus 360, 360 plus 90, it's 270. What am I thinking? What? 360 plus 90, 450. Man, oh man, I better be using my calculator. So it should be 450. So sine of 90 is 1, 450 is 1. These are going to be coterminal angles, and they give me the same sine value. So it's going to look like this, and this is going to continue on. It's going to go that way, and same with the negative values. It's going to go that way. So this is definitely periodic. One complete wavelength is here. Okay, that's one complete cycle or wavelength. The distance it takes to go from here to here is called its period, and that's going to be 360 degrees. That's how far it is between 0 and 360. And its amplitude, its maximum, is 1. Its minimum is -1. So its amplitude is going to be max minus min divided by 2. 1 subtract -1 over 2 is 1. And that's talking about the distance from the horizontal up and the horizontal down, and that's the amplitude for this function. So let's answer some of these questions that we have here. I think I've answered most of them, but let's give it a shot. So we're looking for the maximum. The maximum value is going to be +1, and that is going to be the largest value in the y-axis, the largest positive value. Minimum, that's going to be the largest negative value in the y-axis. And you know what? +1, it's -1. I don't care about this definition. We know the maximum is here. It's the top that we can go. We know the minimum is here. It's the lowest we can go. So amplitude. Amplitude is given by max minus min divided by 2. And in this case, it's going to be 1 unit. I think. Yep, that's what we worked out. The period. The period is 360 degrees. So this is the horizontal distance to complete one wavelength, one cycle, one period, one wavelength. They're all the same. In physics, you call them wavelengths. In math, we call them cycles or periods. Same thing. X-intercepts. Well, there's an x-intercept here, which is at 0, 0. There's an x-intercept here, which is at 180, 0. And there's an x-intercept here at 360, 0. So the x-intercepts are at x equals 0, 180 degrees, and 360 degrees, if we're just looking at this wavelength between 0 and 360. There's other x-intercepts as we go in both directions. Y-intercepts, well, it's at 0. It's crossing the y-axis at 0, so the y-intercept is 0. Domain. Well, for one cycle, if we're just talking about one cycle, then it's going to be from 0 to 360 degrees. If we're talking about the whole curve that goes on and on and on forever, then theta can be anything at all, and it keeps going in both directions. And that's the answer I'd probably be looking for more than anything else. When we're talking about range, the range is going to go from a maximum and a minimum. So its minimum is -1, and that's sine theta. So sine theta, no matter what theta is that I put in, it's going to go from -1 at the bottom up to 1 at the top. You could also say -1 y to 1, but you know, it doesn't matter to me which way. Okay, so what we need to be able to do is able to graph this quickly and accurately without a lot of time. And so I'm going to have you memorize some important things about the sine curve. Number one, here's a little memory aid that might help us a little bit. If we think about the sine curve starts at 0, 0. So it goes to 0. And then it goes up. The sine curve always goes up to its maximum of 1. And then it comes down. It goes through 0 again. And then it goes to -1. So these are the y values. If you think about the x values is 0 degrees, 90 degrees, 180 degrees, 270 degrees, and then back to 360 degrees. So if we think about this, we can use this to sort of help us with the sine curve. The sine at 0 degrees is 0, at 90 degrees is 1, at 180 is 0, at -1 is 270, or at 270 is -1. Let's take a look at how I would go about doing this. I think I would just sort of start off and so I'm going to go up by 90s, but I don't want to go 90, 90, 90, 180, 270. That's going to be too squished in. I want to extend this out a little bit. So I'm going to go 1, 2, 3. I'm going to make that 90 degrees. 1, 2, so 1, 2, 1, 2. This will be 180. 1, 2, so this will be 270. 1, 2, so that'll be 360. So this question says sketch the graph of sine theta on intervals of 90, so I'm going up by 90s, from -360 up to +360. So I've gone up to +360, and now I have to go down to -360. So boom, boom, -90, boom, boom, -180, boom, boom, -270, boom, boom, -360. Okay, so there's my horizontal axis. Now my vertical axis. I know the maximum my sine can go up to is 1, so I'm just going to pick some place here to be 1. I make that 1. And so if 1, 2, 3, 4, 1, 2, 3, 4, so that'll be -1. So this is my vertical axis, this is my horizontal axis. My horizontal axis is theta, my vertical axis is sine theta. And then I'm going to go through this and put in what I need to. But I'm going to do it relatively quickly. I'm going to remember that sine curve starts at 0. So there's sine curve always starts at 0. And then I'm going to remember that sine goes up to its maximum at 90. So it hits a maximum at 90. And then I know that it comes back down and hits a 0 at 180. Then I know that it comes down and hits a minimum at 270. And it comes back up and hits 360. And so my curve, now this one looks a little bit different than the other one simply because of the way I've condensed the axes, but it's the same shape. And you'll see that you've got the same sine curve that's happening here. And this was done by me knowing where something interesting happens. So something interesting happens for the sine curve every 90 degrees. So every 90 degrees I either hit a 0, a maximum, or a minimum. So sine starts at 0, 0, you got to remember that, and it goes up. Every 90 degrees it hits something interesting. So 90 it hits its max, another 90 it hits a 0 coming down, another 90 it hits a minimum, another 90 it hits a 0 again. So coming the other way, so if I'm going this way now, so following the pattern, I'm going to go down, and after 90 degrees something interesting happens. So I'm going to hit my minimum. Another 90 I'm going to hit 0 because I'm coming up. So I came down and I'm going back up. After another 90, I'm going to hit a maximum again, and then I'm going to hit a 0 again. And I come down like that. So what we have here is we have the sine curve being drawn from +360 to -360. And those are all the important points on it. Okay, guys, you got some homework to do. Memorize this and be able to do this quickly.